be given n value, for example n equal to. So we need to generate valid open and closed parentheses. So one is this is valid because you have two open braces and two closed braces, and this is also valid. You have two open braces and two closed braces. For example, if I see this is invalid because the closed brace should come before the closed one should come after open brace, right? And even this is also invalid. What else? Even this is also invalid. And what else do we have? Even this is also invalid, right? So you understood, right? So you will be given n value. We need to return valid parentheses, open and closed, well formed parentheses. So all the combinations should be written. So one thing for sure, what did you understand from here? What did you understand from here? So why it is not why this one is invalid? Can you tell me, is this valid? For example, n equal to 1, is this valid? Why it is? Yeah, so beginning one should followed by the closure parenthesis. Prior to that, for example, I'll give you one more use case. I'll give n as 2 and you have open, close, close, open. Is this valid? Why? Why it is invalid? Yes, right. So what is happening here? Yeah, so if you closely see, this is not following the convention, right? How do you know that this is not following the convention? For example, I give n equal to 3. This is valid, right? So this is valid. I understand your point, but can you come up with the triggering point so through which you can generate a logic? So yeah, so that's the point, right? So whenever you see here at this point in time, by this time, so number of open count is equal to 1, but number of closed counts, right? If you see number of closed counts, which is equal to 2, that's why it is invalid. So when do you generate a valid parenthesis? The closed count, the closed count should be less than or equal to open count, then only it will work. For example, you given n equal to 2, then you have open count, two open counts, so you have a closed count. It means I can say that this is valid at this point in time. I can say that this is valid because I have two open counts, one closed count, still it is valid. If I go further, still I could say that the current position is valid because I have two open counts, so the two closed counts, so that it is valid. But if I add one more, right, definitely it is invalid. So forget about n. If I add one more, definitely it is invalid. So the triggering point is the closed count should be less than or equal to the open count. So you cannot make sure that so one base case you understand that whenever your closed count is greater than open count, you definitely make sure that that is not valid combination, so you can terminate the process. This is clear, right? This is clear, right? So let me see how do you think about this problem. So you have n equal to, so let's take n equal to. So I'm taking this is a purely recursion problem. You have to see all possible results. So you have to see all possible results. Let's see how can you do that. You will be having two parameters. One is considering open count and another is considering closed count. So this is open count, and the second parameter is talking about closed count. So initially both are 0, so that you are having empty. So you have two possibilities here. I can start with open. If I start with open, so definitely the open count will increment by 1, so there is no change in closed count. Or I can directly go with what? I can directly go with closed count. If I start with closed count, definitely open count becomes 0, closed count becomes 1. So obviously this combination is invalid, so that this tag frame will get terminated, because the closed count is greater than open count, right? So I am just taking two variables. One is closed count, another one is open count. So sorry, this is open count and this is closed count. The closed count is greater than open count, so that I can terminate this tag frame. So that I feel that this is only the valid case. Now let's move on. Now you are here. Till now you have one open brace. Again I have two possibilities. Let me go with open count. So if I go with open count, if I add one more open brace, so definitely it will be something like this, and the open count becomes 0. So, sorry, the open count becomes 2 and closed count, there is no change in closed count. For example, if I go other case, so there are other ways, right? So if I go other case, till now we have only one open brace and there is no closed brace. Now I'm trying to add closed brace. If I add closed brace, definitely this is going to be 1 comma 1. So I feel that still these are valid. Yes or no, please? Still these are valid, correct? Yes or no, please? Till now it's valid, right? Now let's move further. Let's move further. So I'll go further. So I'll try to do open count. So I'll try to make open, so that this open count becomes 3, closed count becomes 0. Now if you closely see, my open count is greater than given n. So I need to generate valid parenthesis till n, right? So that obviously this is invalid case. Why it is invalid case? The open count greater than n, so that obviously this is terminated. So I don't move further. So this is invalid stack frame. So I'll just get terminate this. Then I have other possibility. So what I do is, earlier I have two open counts, so that when I try to go with open count, definitely this is invalid, so that I'll try with closed count. So if I go with closed count, so what will happen? So you have two open, one closed. It is going to be 2 comma 1. Do you see this is valid? Do you see this is valid, please? Till now it is valid, right? Because the closed count is always less than or equal to open count. Now again you have two possibilities, right? So again you have two possibilities. You don't know, right? So you need to see all possibilities, buddy. So you don't know unless your stack frame gets terminated. You have to see all possibilities. You don't know, so you don't have any chance. So this is open, right? So what I do, this is one. See, again I try open. So when I do open, so it means for this input I am just adding open. So then it becomes 3 comma 1. Again if you closely see, this open count is greater than n, right? So that this stack frame will get terminated. So I don't want to proceed further. Now I want to see only closed thing, right? So let me go for it. I want to see closed one. So that what I'll do, earlier I have two open braces, one closed brace and one more closed. Then you get 2 comma 2, right? Now this is where, now do you know that this is your valid result? Do you know that this is your valid result? How do you know that? How do you know that? By seeing this in this output, you understand that this is valid result, but you have these values with you. How do you know that this is valid result, so that I can store this result? Yes, buddy. It means even 1 comma 1 also both are equal, right? Here also both are equal, but this is not valid result, right? Right. So the thing is, when do you find a valid result? When do you find a valid result? So your open count and closed count. so your open count and closed count both equal to n, then you found a valid result. So you just store that result. So you found a valid result 1. That's it. So once you found a valid result, there is no further process. You are done with it. So you are done with it. So once you're done with it, so it will just move backward. If you closely see, where did we start it? So closely see, where did we start it? So when we have 1 comma 0, we went with open count and we figure out one possible solution. Now let's move on to the closed count. So from 1 comma 0, when you go with closed count, it becomes 1 comma 1. Now again you see all possibilities. So let me make it little far. Okay, let me erase this. Yeah, this is yours, right? So you have one open count, one closed count. So let's see that. So now you are here. Now let's see, again you have two possibilities. Other end you can have open count, so that open closed open. So you have open count now here. So what will be happen? So you have 2 comma 1 because you opened, right? So you opened a braces, it becomes 2 comma 1. Now again, I'll track this later. So first let me track this, that again you have two possibilities, open and close. If you go with open, so let's see. If I go with open, so what will happen? You have open brace, close brace, and open, and again open. So it becomes 3 comma 1. So you already understand that earlier open is 2. You increase it one more time. So the open count becomes 3. So which is greater than n. So this is get terminated. So there is no further processing. Now you go. So you have only one option left. So you're done with open. So you are trying to go with closed. So this is previous one. So that I am just adding close here. So it becomes 2 comma 2. Again you see the you found a valid result because open count and closed count both are equal to n. So you found a valid result, so that it's time to take that result. That's it. It's time to take that result. Now let's move further. So again you have one more. The final thing is, so, yeah. This is close. Yeah, open close open close. You found it. Now let's move here. You tried from open close. From here you just tried closed count. You try to close it, then you figure out a solution. Now let's move here. So this 1 comma 1 is having one open, one closed brace, right? Now you tried with open. Let me try with close. So it means you have open close and okay, so you have open close. Okay, so then you are trying with close. So when you try with close, it becomes 1 comma 2. So the close count is greater than open count. So obviously this is invalid. So this is invalid. So that you, I think if you closely see, you are done with complete processing. So the complete, you have seen all the possibilities, and you found two valid solutions. So you just need to return those two valid solutions. Understood, man? Understood. Yes, that's correct, right? So because you have to generate exactly n valid parentheses. So you should have n open braces and closed braces. It's not the total length. So you should have only n open braces and n closed braces. If this value is any one of the value is greater than n, it means you found a invalid combination. So you just terminate it. So let me, if you miss previously, please watch again so that it will be smooth. So I'll go little quick. So initially you have open count and closed count, right? So what I does, I have two possibilities. I can open or close. If I go with open, so it becomes 1 comma 0. If I go with close, it becomes 0 comma 1. So in this case, it is invalid because closed count greater than open count. So you just terminate this stack frame. Now again, what is the possibility? Now here also you have two possibilities. You can go with open open or open closed. If you go with open open, so if you go with run, so you are trying to increase just open count, so it becomes 2 comma 0. So if you go with this case, you are just increasing closed count, so it becomes 1 comma 1. Now again you have two possibilities here, open and closed. So if I add open to the current string, so it becomes 3 comma 0. This is also invalid because your open count greater than n. So when it is n, so because you need to generate exactly n open braces and closed braces, so the combination of that you need to generate valid parentheses. So obviously this is invalid. Now let's move further. So if I go with closed, so if I go with closed, what will happen? So whatever value you have earlier, so earlier we have value uh, open brace. Now you are trying to add closed brace, it becomes 2 comma 1. Again you have two possibilities. So if you go with open, so open closed open, so it becomes 3 comma 1. So this is again invalid. And if you go with closed, so then it will become open closed, it becomes 2 comma 2. So whenever you see this, right, so whenever open count and closed count is equal to n, so it means you found a valid result. So just take that input, that's it. Take that output which is generated by this recursive call. Now let's move further. Now we are trying to tackle this one. Let me do that. Yeah. So what is going to happen? Again, you have two possibilities blindly. So open, closed, open. So it becomes 2 comma 1, and open, closed. It becomes 1 comma 2. But you understand that the closed count is greater than open count. So this gets terminated. Now you have only this one. Uh, yeah. So you have only this one. So now let's move further. So open, closed, open. So it becomes 3 comma 1. So obviously this is also get terminated because the open count is greater than n. Now you have left with one more possibility. So let's do that. So you have open and closed, because right side is closed, left side is open. So that you got 2 comma 2. So you found a valid combination here. Just take that result. Clear, right? Clear, right, everyone, please? Now, tell me, what is that time complexity? This is recursive and backtracking, right? It's very tough to come up with exact time complexity, but we can give. You need to think that how your code is working, and based on that, most of the backtracking problems, right? You cannot come up with 100% time complexity. It is for sure, because unless you are too good in mathematics, you can come up with the exact formula. But the thing is, the interviewer will be satisfied if you come up with uh, the middle one. So how your algorithm is going in, and how are you coding it. So based on that, if you come up with a reasonable one, so they will be satisfied. So let's say how do you know the time complexity of this? Okay, so simple. What is the length of the valid well formed parenthesis? Tell me, what is the length of for the length of the why it is 4? Yeah, I understand it is 4. That's correct. Can you tell me in the form of yeah, can you tell me in the form of n? Yeah, that's why it is 2n, right? The valid parenthesis size will be 2n, right? So yes, so it is 2n. So it means how many combinations you have in worst case? 2n combinations, na buddy, please. Yes or no? in of course we don't traverse till here, but if you closely see, in worst case you have two n combinations, means all these are combinations only na. If I closely see, all these are combinations only, but few of the combinations having length smaller, but a valid combination is having exactly 2n right, so 2n length. So but we should consider what do we say, worst case, so that at max you have 2n is the length of a valid 2n, at max you have a 2n length of a string, and each combination string will have two possibilities, right? One is including or excluding, yes or no? Is it not, buddy? Each combination is having two possibilities, right? Yes or no, buddy, please? Is it, if you little, no, that is not complexity, that is not complexity. First, this is at max you have 2n length valid string, right? I'm saying 2n length valid string, and each valid string will have two possibilities, right? This will, so it means, what do you think? So it is a exponential na, so you can take it as a 2 to the power of 2 power n, right? Everyone understood, please? Everyone understood this? Akash, are you there? Okay. So the point is, you have at max 2n length valid string, and each string will have two possibilities. So this is 2 to the power of 2 into 2 to the power of n. And what is one more additional thing we are doing? Okay, so this is number of possible solutions you could get, correct? Yes or nobody, please? This is number of possible solutions you could get, right? Everyone, please. Okay. Now you found a number of possible solutions. But what are you doing in each possible solution? In each possible solution, are we generating a string or not? Yes or no? Yes or no, please? This is not generated string, nobody. Come on. Yeah, generated string, right? It means, yeah, so that's what I'm saying. You have 2 to the power 2n combinations. It can be valid or invalid. In each case, you are going to generate a string. That length, the length of that string at max will be 2n, right? 2n. So obviously this 2n we can ignore that 2, so that this is going to be n into 2 to the power n. So do you understand this? This is the time complexity. But it is less than or equal to this, but if you closely see, this is how it is. Do you understand this? Yeah. So one way is, yeah, let's go further. First thing, first thing, what could be the possible substring, valid substring? You can say that it is 2n, right? This is clear, right? So I can just note it down. You can generate a possible valid parenthesis string as 2n. So this is clear, right? Till here it is clear, right? So if you are clear on this, it means we went down till 2n, right? So we went down, our recursion tree went till 2n, right? Yes or no? So the recursion tree went till 2n length string. So, and each string will have two options, whether include or exclude, at this point in time we just terminated the stack frame, but if you go further, again we it will just take one more step extra, because if you go further it becomes 3 comma 2 2 comma 3, so obviously both will get terminated. So this we didn't do it. We found a valid solution here, so that we just terminate the stack frame here. But you pick up anything, right? So you understand that this is one possibility, this is one possibility. For this possibility you have two two for this string you have two possibilities, and from this string you are able to generate this string. If you closely see, this string has two possibilities and you traverse with one of the possibility and you get this one. From here again you got two possibilities, you get this one and this one, and from here you get two possibilities. It means you got a result, right? You got a result. It's not blind spot, right? It's not blind spot. You are trying to see all possibilities. It means at max you have possible, at max you have 2n length of the string, but to generate this 2n length of the string you start with 1, right? And each one will have two possibilities, plus or minus. So it means it is going to be 2n is the max possible solutions. I can say that 2n is the max possible solutions, and each one will have plus or minus. So it is going to be 2 to the power of 2n. Till it is clear, right? Till now it is clear, right? Or do you need so it is no confusion, right? So it means I know the point is this 2n sub problems, right? You generated 2n sub problem. It means 2n possible strings. You can say not sub problems. 2n possible strings. These are the 2n possible strings. So all you can say everything. So of course it is one, but we always consider the max one, right? All these are possible strings. So the max length of the possible string is 2n. So each one will have one plus or minus. So it is going to be 2 to the power of 2n. And if you closely see, it means these are the sub problems. We generated 2 to the power 2n sub problems. As we generated 2 to the power 2n sub problems, in each sub problem we are just copying the result, right? This is what generating the result or not? We are generating this string or not? Each sub problem we are generating the string or not? Yes or no? This is the string you are generating, right? Yes or no? So this is a string, we are generating the string, right? So if you are generating string means at max you have the length of n, so that these are the sub problems, and each sub problem you are generating the string, so which is going to n into 2 to the power 2n, so which is less than or equal to that. But if you, there is a mathematical theorem behind this, the mathematical theorem stating that the time complexity will be 4 to the power n by root n. But I still don't understand. There is a Catalan number concept. uh, I still didn't go through that, but if you get a time you can go through it. But this is also, if you convey this also, it is 100% fine. Okay, so you don't need to be too math about it. uh, that's it. So what is the space complexity, please? What is the space complexity? First, with respect to stack frames, can you tell me with respect to stack frames? How many stack frames gets active at any point in time? Let's see what is the maximum length, right? So you know, right? So yeah, so let's see what is the maximum length, right? So this is max valid length, right? This is max valid length. Hope you are getting it. So you have 1 2 3 4 5 at max 5. So what do you mean, what do you mean by that? This is max valid length, right? Hope you understand this, right? So when one of the stack frame gets activated, the other one gets terminated, right? So if you closely see, this is how it is, right? So you have open close, and you have open close, and again open close. If you go open close, so then the here n equal to, right? So here open count is greater than n, so this gets terminated. It means still here you got, if you closely see, still here you got two opens. Then what else the possibility you have? So you go with close, sorry, you go with one close, so obviously this is going to be something like this. Then again you have two possibilities from here. either you can go with open close. So again this becomes something like this, open open. So obviously this open count greater than n, this gets terminated. Now you come here, when you come here it becomes 2 comma 2, so it becomes open open close close. So if you closely see, though you have the complete tree, right? So though you have the complete tree, so if you closely see, this is the active stack frame you have, right? This is the active stack frame you have, because other, when you are processing this one, others one were already terminated. So if you closely see, this is the active stack frame count you have, so which is at max 2n plus 1. So you have n as 2, so which is you have 2n plus 1 active stack frames. So it obviously with respect to stack frames, the time complexity is how much, please? Sorry, space complexity how much? Yeah, yeah. So for stack frames, yeah, you can say 2n plus 1, so which is equal to order of n. So these constants you can ignore. It's a precise English. That's okay. That's okay. That this is always constant. It's okay. Yeah. Now, yeah. So let's say other way. So what? How many? How this is with respect to stack frames, and let's see what is the result will hold. How many values a result? How much of space this is going to take? How much of space this is going to take? Actual space. We'll have two results in the array. Yeah. So, but if you closely see, in worst case, if you think that, so you have 2 to the power 2n sub problems, right? And each sub problem uh, will hold the result of n, right? Holds a result of n. So which is n into 2 to the power of 2n. But if you closely see, this is not active all the time, right? So at max, how many, this is not active all the time, because when you are considering space complexity, right? I think this is not valid. Why? Because we are not holding each and every sub problem result in the memory. Correct, right? We are not holding each and every sub problem result in the memory. Correct? Because if you closely see here, when you are holding these sub problem results, other sub problem results, right? Whatever sub problem results you get here or you get here, which already get terminated, it means the memory allocated for this is already been deallocated. So obviously this is not n into 2 to the power 2n. But if you see exactly how many valid strings it can generate, based on that you can determine. So these are the valid strings, right? So how many valid strings it is going to generate, based on that you can determine. But it is greater than or equal to definitely n. So it's greater than big O of 2n. So yeah, you can figure that out. Fine, clear. And it's very tough to go very precise, man. So with respect to backtracking problems, we have to explore on it. Everybody is clear? Yeah, yeah. So that's what I'm saying. So it's greater than or equal to 2n. So it's greater than or equal to 2n. So that's what I said earlier. Okay. Now tell me how to write the logic. So what are the parameters it needs? Tell me please. You have private. What I will do, list of strings, you can take it as result, new array list. Okay, so private index, why, where do you find the index? Do you have array here? Okay, so one is for sure, so we need a n value. What else? What else? Yes, perfect. So you have closed count and you have open count and you have n, and what else extra? Do we need any extra? Do we need any? Yes, so we need that individual strings, right? So it means string current. So let me move it. Perfect. So now tell me what is the base case? Base case is for invalid case. What are the base cases for? So one is yeah. So yeah. Let me move. Let's go this way. So when your open count greater than closed count, then it is invalid, right? So it's time to terminate this tag frame. How do you terminate? Just to return. That's it. One is done. And what is other invalid case? Yeah. So when open count greater than n, or the closed count also greater than n, right? So if the closed count greater than n, again you terminate. And what is the result holding valid case? Yes. So at this point in time, so when open count is equal to n and closed count is equal to n, so you found a valid use case. At this time you need to hold the result, right? So result dot add, so that is present in this current string, so that this string will have the result, so that you will just say result dot add of current, then you will just return. Otherwise what is your job, buddy? Otherwise what is your job? Yeah, so I'll call generate function. Others also please respond. So generate function, one time I can increase the open count. Okay, I'll just increase the open count by 1. So there is no change in closed count. And there is a n remains same. And to the current string, I'll just add open brace because I am increasing the open count. Similarly, I will go with other case, generate. If you closely see, this is what we did, right? If you closely see, don't get confused here. So first we tried with open count. Where is it? So first we tried with open count. Then once we see all the subtree possibilities, right? Then we go with the same closed count, so same open count. Then we tried with closed count, right? So that's how we did in every recursive call. So what we are trying to do now here? So we are going to generate closed count. So we will take the current open count. So this is more important. Generally you will get confused here, and we will try to increase the closed count, then n, then current plus closed. Yeah, it should be closed greater than open. Yeah, so when the closed count is greater than open count, I think I have, by manipulating this, I just forgot it. Yeah, so that's it, right? This is what the recursion code. So this is going to generate that huge recursion tree, and it will just do that. So let me call this generate method with open count 0, closed count 0, with the given n value and with the empty string. That's it. Then I will just return result. See how simple it is. If you understand the concept behind it, you can easily do it. It's very doable. Done. That's it, man. Is this clear? Here, right? Here I'm adding, right? So here I am line number 5. We are just returning here. We taken as an instance variable, we just add it. Okay, so yeah, I cannot complete other one today. Probably we will. So I request you to practice this 784, which is more or like same as these problems. Uh, what I'm doing is, for now, for example, if you see here, right, word break to some Sudoku solver and queens kind of problems. Few problems needs other data structures knowledge. Whatever which can be covered at this point in time, I will cover them. Then we will revisit when we discuss about graphs. We can solve this word break too with backtracking. So we'll come back. Uh, Try solving this decode string. Let me stop the video.